Welcome to ActiveMQ Essentials. I'm Jamie Goodyear. Today we're going to be introducing KahaDB. That is the default message store that underpins your broker. Up next. So let's dive in. When we're looking at ActiveMQ, what we need to understand first is that ActiveMQ is providing an implementation of the JMS provider. Producers are going to be sending messages into a broker to a specific destination. That could be a topic or a queue. And then we'll have consumer clients which have registered or subscribed in to be able to get those messages from the destination. KahaDB in this model is actually this part here, the message store. That is where our persistent messages are being saved and written out to disk, so that way we are ensured under JMS that that message is going to be able to reach the consumer, i.e. if the broker is restarted and there is a message in the store, it means when that consumer comes in looking for that message on the queue or topic, it'll be available so it can be picked up and read. So let's dive in deeper to what does this message store provide. So as the default, the key features that we have here are going to be that it provides us transaction support. So that is our XA transactions with two-phase commit. This is what it's going to allow us to do all of our more enterprise flows where if you had to roll back a message, you can do that. We have fast recovery time. The reason we can do this is that we have very efficient journaling and indexed storage. We're going to show some slides of how this all works, but all you really need to know up front is that if the broker was to go down and then be restarted, because we've indexed and done a very good job at making it quick to load, we can restart this broker really quickly. Persistent messaging, so that's all about having durable messages. A durable message in this case is just that you send it into the system, and since it's been persisted down to disk, it means that you can now pick it up later, even if you've had multiple restarts of that broker. It's going to be there. And then we have the efficient storage. This is very important because you can imagine you're sending in data inside that message. You need to be able to write that to a disk, but you also need to be able to manipulate it. You need a reference to that message. You don't want to be pushing all of that data through a broker. You'll eat all your RAM. You need to have an efficient way of passing references and being able to find things by references. So that way when random consumers connect in, we can grab this data and provide it to you. So let's take a little bit more of a deeper look about the core concepts of how KahaDB works. At least what does it provide? These are going to be the general things you're going to hear about KahaDB, so you need to understand what all these terms mean. First part is that it's journal-based storage. So when a message is persisted onto disk, it means that we are writing it to a journal log file. The file that we actually have is effectively just a file that we are always appending to. So as events, commands, etc. all come into the broker, that is being written and appended to the end of these log files. Now we're going to see many, many log files when you get into the broker, and we'll see that when we get down to the terminal. But effectively, lots of files, and that's going to have what that message is, the data about it, subscribe, unsubscribe events, etc. All of that's going to be in there in chronological order. These logs are stored in a directory, and typically you're going to see DB1, DB2, etc. Being written out to disk. The indexing, what we mean here is that alongside the fact we are journaled, KahaDB is maintaining index file that maps destinations, so that's your queues and your topics, and the message ID to the physical location in the log file. So what that means is that each one of these files, you'll have like a message lands in, here's its data. We now have the ability to say, hey, for message ID 123, there's some particular offset, and then we can find that file so we can pull that data out of disk and be able to reconstitute it so when the consumer client gets that message, it's all there. These indexes are stored as a B tree-like structure. So effectively, think of it as a memory mapped structure that has a bounce tree. This is done for each of our destinations. So we can very quickly in memory get to that reference, and then when you have that reference, you can then get back to pull that data off a disk. We're storing all these message references in an index tree so that we can have that rapid update time. So it's very, very quick to find a destination, and then you find a place that it needs to fit. Checkpointing. So when you hear about checkpointing in KahaDB, what this means is that we have a periodical part in which the in-memory B tree gets persisted out to disk, gets down to store. We'll see a bigger architecture diagram explaining this, but effectively what this is doing is allowing us to take what's in memory and we write it down to a disk, so we have a place that we say, hey, here's the state as of this point of time. Message acknowledgement. Okay, so when a message is acknowledged, we update the state in the index and then becomes eligible for us to remove. So you imagine you have in our tree and on our log, we have our data, and as we acknowledge that that message has gone through, it's been persisted down, a client came in, it pulled the message out, it's now acknowledged that it's been consumed. Now we can clean up. And when we get to the point that all of our file is full of these acknowledgements saying, hey, everything in here has been consumed, we don't have a reason to keep this around anymore, so we can finally remove that and be efficient with our disk usage. If we weren't doing this, we'd end up in a scenario where the DB would grow uncontrollably over time, and our disk would run eventually out of space. Recovery. So when we want to talk about recovery with KahaDB, what we're talking about is when we restart our KahaDB, we read the most recent index snapshot and replay any unapplied journal entries to bring our index up to a consistent state. What that really means is that when we boot up, we can read back from what's inside of our metadata store, and we can be able to determine, hey, where are we? Where were we to the last time we left off? In theory, you could start up the broker without any of this metadata, and what it will do is it'll read all of your log files and try to replay everything and figure out what the state is. Given if you have a lot of DB log files, obviously this can take quite some time to do it, so having that metadata store that's persisted to disk and being able to rebuild our cached memory set of references and B trees make it quite fast and efficient to be able to get the broker running again. Of course, this is a very deep topic, and there's a lot more to all of this, so this is a very introductory level explanation of what's going on here. Finally, file compaction. So all of our old log files that contain just the acknowledged messages, we get rid of those to free up our space. Everything we're doing is trying to keep the amount of space we keep on disk reasonably minimal. So yeah, we do have our journal, which is going to be the full fat information coming into the broker, but our metadata store and all that is only about references and trying to keep just what we need on disk to make it fast and efficient to use. Now, let's just talk a little bit about KahaDB structure. So once we start up our broker, and I'm going to show this on a terminal, we're going to have in our data folder a KahaDB folder. Inside of that, you're going to see a collection of files. You'll see all of these DB dash some number, so DB1, DB2, etc. Those are our data journal files. That's where we're seeing that appended file that's completely rolling over, and we're generating more and more of those files as the broker is used. We have a DB data file. That is the current index data, that snapshot of our B tree that's in memory. You'll also see a DB redo and free files. What those are about is when something is going through a transaction, something's not complete, this is the bit of persistent data that we use to help implement that functionality. Finally, you'll also see that there's a lock file. So we use this to prevent multiple brokers from accessing the same storage at one time. You'll see this in failover, and when you want to have your active passive kind of setup of a broker. That is what its purpose is there for. So with that being said, let's get into a little bit of a discussion of the high level of how this actually comes together. In the diagram, what I've put here is the three main structures you will probably be hearing about when you're using Kaha and you ever have to investigate it. We have our DB log journal file, so that's all those DB-1-2 files written out. That would be in the Kaha folder. We have in memory, so that's running in the JVM, the metadata cache. That contains that B tree structure per destination. So everyone else messages, imagining on a queue, they're structured in there in memory. So that way, when we need to get a reference, we can grab it from there. And from there, it has the links saying, hey, this is in DB log 2. It's an offset of, say 400 lines down. And then it can pull out the data from there when it needs to consume the actual message data. And then when we are checkpointing, all that then gets sent to the store, the actual written out db.data file. And that's our snapshot of what was in the memory structure. So we have that quick rebooting. Of course, what's in the data store as well, that's pointing back to all those locations in those DB files. So let's have a little look now at that DB log file. As mentioned, this is a rolling log file of all the events that are coming down. So that's your messages, acknowledgements, subscriptions, unsubscriptions, cancellations, transaction boundaries, etc. That's what we're recording in there. These are always appended to the end of the file, so it's got very rapid update. And access to this data store maintains that metadata tree to all of our indexes. So that is the key part here. This is where the real data lives. And all of the memory, metadata, and what's on the store, it's pointing to these files. So these files are very important. You do not want to have one of these files become corrupted, or someone, a minister go in and accidentally delete one of these files. This is core to the running of your broker. The in-memory data cache, this is all of the destinations are going to have their own B tree, tracking locations against the DB log. These are tracked as message ID and some offset, so that's how it's able to find things. The cache, as I've already mentioned, is periodically written out to our store. That store is where all the complete metadata for broker has been written, so that is what we're able to, when we restart a broker, it'll start there and it gets us to the running state as rapidly as possible. So with all this said, let's get down to the terminal, fire up a broker, and then I'll show you in the KahaDB folder where all these files live, and we'll take a little look at what's going on under the hood. Okay, let's take a look where we're to here. I have downloaded a Apache ActiveMQ 6.1.6 kit, extracted it, and now I'm in its bin folder. Inside of here, I can start up our ActiveMQ broker and send to the terminal all the console messages. When it starts up, we'll see here that we have AMQ 616. It's up and running and it's available for us to use. I'm going to switch over now to another terminal. In here, I've set up a very simple demo to just make a publisher and consumer of messages going to a message queue. We're going to use this to populate the broker, so that way when we go over to take a look at the KahaDB, there will be some data written in there. So very quick look at what we have in here. I have a publisher, and inside of here, and I'll just do this to highlight the syntax, we are setting up a connection factory to the broker. We are going to use a queue, and inside of here what we'll be doing is sending along effectively the alphabet as a set of messages. That's our message body. And we'll see about 10,000 of these will land onto a destination. Once we do that, we then go over to a listener who is going to connect to that location. And it will be connected to the queue, and it will just pull all 10,000 of those messages out. So we're just going to quickly run this code, and once it's completed, we'll see that KahaDB has a bunch of data in there. All right, at this time, we've now sent 10,000 messages into queue. Let's go over to the KahaDB for this instance and take a little look around. So we're going to go into the data folder and then KahaDB, and we'll start seeing some of these KahaDB files we discussed earlier. We have db1 log file that will contain all the message data from those 10,000 messages we just sent in. The db.data, which is going to be our checkpoint of the in-memory B tree. And we can also see the beginning of a DB redo. We actually haven't done any transactions, but that file is created, and the lock file. So let's take a quick look inside of this db-1 file. This is going to be binary setup, so there's going to be a lot of data in here that we won't be able to just human read. But if I go down a little bit through, we can actually see some of that message data, i.e. we see the alphabet that's been placed in there for the messages that have been put into the store. And if we were to go through it, we'll see that again and again. If we were to take a look at the DB data, of course, this should also be binary data. We'll get a little bit of here that we can read, but once we scroll down further, there's going to be a lot of data here we won't be able to view directly. But that does give you the idea of how that's being stored. If we were to head on back and consume these files out, so I'm just going to run the listener application that's going to consume those messages out of the DB, and then we head on back, we should see that the data here should be reducing. Obviously on DB1, this is going to be just registering all these files were then asked to be read out, but the actual tree should be reduced because those messages have now been consumed, so they're not going to be available. The idea is that a single message comes in, you can only consume it once. So let's just open up to db.log-1log. And if I was to go all the way to the bottom, we're just going to be seeing this would all be coming along events saying, hey, we've read this message, we've consumed the message. And that's what we're effectively doing there. It's saying message ID has now been consumed. So with all this being said, this is our gentle exploration into KahaDB. There is a lot more depth into what we can do with KahaDB. There is a plethora of options for configuration. Something that we can show you is if we go into our configuration, and I'm just going to open up now our ActiveMQ XML, just so that we can see where all those settings will be set. And we're going to just scroll on down to our data store. So past all of our policies, management console. The most basic setup we have here is just saying, hey, here's the KahaDB directory and where it lives. In most production KahaDBs, you're going to end up seeing a lot of parameters appended in here for how you want this store to operate. And we hope to do future follow-up videos to explain what some of those mean and why you would use all these different options. And on that note, we're at that point in our video where we always ask you to please like and subscribe to our videos and hit the notification bell, and we'll see you on the next video. Have a great day. Cheers.